This video we're going to start solving our trig equations. Today what we're going to be doing is solving trig equations that are the more basic type, where we're going to be looking for from 0 to 2 pi to solve just some basic trig equations. For instance, we might solve an equation that looks like this. The sine of x equals negative root 2 over 2. So what we're basically looking for here is just to know, first of all, which quadrants are we going to be in? We're talking about sine, and sine again is that y coordinate. So sine is going to be negative in quadrant 3 and in quadrant 4. And then we want to know what angle are we looking at here. So when we're in quadrant 3 and quadrant 4, and we're looking for a root 2 over 2, we're talking about the pi over 4s. And so our solution to that equation would simply be 5 pi over 4 and 7 pi over 4. Now typically what's going to happen is we're going to get two answers to our equations, because what we're doing is looking for those values all the way around, and there's usually some symmetry going on where we've got duplicate values. There are exceptions, of course, and we'll get into those in a little bit. So let's try another one here. We got the tangent of x equals the square root of 3. So again, first thing you want to do is figure out which quadrant am I in. And the tangent's positive, and so I know that I'm going to be in quadrant 1 and quadrant 3, because the sine and cosine are both positive or both negative in those quadrants. And from looking for the tangent is equal to the square root of 3, that would be at the pi over 3's. So looking at quadrant 1, it's pi over 3, and down in quadrant 3, it's 4 pi over 3. And so those are my two solutions to that equation. What about one where we've got a secant? So let's do secant of x equals negative 2 root 3 over 3. Now my hope is at this point that you've recognized that negative 2 root 3 over 3 is the reciprocal of negative root 3 over 2. And if I take the reciprocal of secant, I'm going to get the cosine. So what I'm really looking for is where the cosine is equal to negative root 3 over 2. Because again, that's the reciprocal of secant. So again, cosine will be negative in quadrant 2 and in quadrant 3. And then the root 3 over 2's are going to occur at the pi over 6's. So my answer to that, again, two solutions, 5 pi over 6 and 7 pi over 6. And so then what about a cosine like this? Cosine of x equals negative 1. Well, that was a little bit trickier because we're not actually in a quadrant at all. Because if we're looking at the cosine being equal to a whole number, like 1 or negative 1, that's actually going to be on one of our axes. So if we kind of go around and figure out our values here, cosine here would be equal to 1, here would be equal to 0, here would be equal to negative 1. And that is actually the only place that that's going to occur, because it falls directly on that axis. So pi would be my only solution. Now again, typically we're going to get two solutions, but there are exceptions, just like we saw right here with that cosine value, where we'll only get one. Let's get into some more complicated ones where we're going to have to do a little bit of legwork to get these to work. See if I can lasso these and delete it real quick. Alright, just got some leftovers. Alright, so let's look at a problem where we're going to have to do a little bit more work, like 2 cosine of x plus the square root of 2 equals 0. So again, my solution here is going to be to find out what x equals. Now the way to do this is I'm going to try and isolate cosine of x. I'm essentially reversing operations. So I'm going to get rid of that square root of 2. So I'm going to make it 2 cosine of x equals negative square root of 2. Then I'm going to divide by 2 on both sides to give me cosine of x equals negative square root of 2 over 2. Now again, it's one of the more basic problems that we just looked at. So once we find that trig identity by itself, then we're looking for where that value is achieved. So I know cosine again is negative in quadrants 2 and 3, and the root 2 over 2 is happening at the pi over 4's. So it's 3 pi over 4 and 5 pi over 4. How about this one? The square root of 3 tangent of x plus 1 equals 0. So again, I've got a lot of stuff going on here, but I want to get that tangent by itself. So I'm going to first start by taking that square, or that 1, and bringing it over to the other side. So I'm going to subtract 1 to the other side, negative 1. And then divide by root 3. And I don't recognize that one, but I know I can rationalize it. So multiply the top and bottom by the square root of 3, giving me the tangent of x equals negative root, what, that's a terrible looking negative root 3. Let me try that again. Negative root 3 over 3. And so that's going to occur at the pi over 6's, but at first I want to know what quadrant I'm going to be in. Tangent is negative where the sine and cosine have opposite signs. One's positive, one's negative. That's going to happen in quadrant 2 and quadrant 4. And the pi over 6's in those quadrants are 5 pi over 6 and 11 pi over 6. Let's try one more. Let's do secant of x, oops, not sx, secant of x plus 2 equals 0. So first thing I'm going to do is bring that 2 over to the other side. And hopefully at that point recognize that I'm really looking for the cosine values. So I'm going to take the reciprocal of that side, giving me the cosine of x. And the reciprocal of the other side gives me negative 1 over 2. I'm in quadrant 2 and 3 again. And the cosine is a negative 1/2 at the pi over 3's. So my answers then would be 2 pi over 3 and 4 pi over 3. Now in the next video what we're going to do is look at what happens when it's not just x. What happens if there's a 2x or a 3x or something else, and we'll expand upon that.